That's because he's from Louisiana. How would you say that?
All right, I resemble that remark.
Well, you know, I brought my passport because this is Texas. I'm from Illinois. Do you need a passport to get into Texas?
No, you do.
Okay. Am I on the system now? Can you hear me?
Yeah.
Okay, that's the question. I'm going through the camera now. Okay, I want to welcome everybody. This is our first time that we've had a symposium tied back in with SWAT. If it works out real well, we may continue this as an annual symposium with part of SWAT. So I want to welcome everybody here. And I asked, how many people are ornamental turners? Okay, we got some in the audience. And your first timers, welcome to a world of another deep rabbit hole. It is a lot of fun. And it allows you to do a lot of stuff on your pieces. You can simply decorate the bottom of a bowl if you want to with it. Or go really, really advanced on it. There's a lot of stuff you can do. There's some samples of stuff in there. There's samples in the gallery. And look at some of the stuff that people have done. Roy is going to give us a presentation as an introduction into ornamental turning. So it's applicable for everybody out there. So, Roy?
Thank you, Trace. Am I the only Idaho native in here, by the way? Anybody from Idaho? Well, I probably never met anyone from Idaho. I grew up there. I got involved in ornamental turning. I belonged to the Chicago Wood Turners, and we had a MDF machine similar to the one upstairs that got circulated in the club. And there's this gentleman named Steve White. Steve White was partnered with David Lindow, and they made the machine that we have here, which is commonly called a Lindow. But I went to St. Louis and visited Steve, and I was hooked, primarily because it brought together a lot of things. Our house is full. I've made all the furniture. I've got all kinds of balls. And ornamental turning is, generally speaking, little stuff. So there's still space. So I invested in the machine. I will say that I've been working at it like roughly 20 years. But I think some of those years have been maybe as many as 5 or 10 of those years have been the same year repeated. I'm not sure of advanced. And as Trey mentioned, ornamental turning, there's a long, long history. I'll talk about it a little bit. But essentially there's one lifetime. You've got one lifetime, and there's like 15 lifetimes of material to learn here. So you're going to end up, if you do it, and you are doing it, you probably are focused in a specialty little area. What happened? Oh, I need my presentation. Where is it? There we go. I'm from Naperville, Illinois, which is a southwest suburb of Chicago. It's roughly 1,000 miles from here. There we go. My objectives today, of course, is to introduce ornamental turning, and hopefully those of you that are seasoned, maybe there'll be some little thing that I do that might improve your work or might show you a different way to do something. I want to primarily illustrate the basic spindle rocking mechanism. Some machines, by the way, don't necessarily rock, they translate. Rocking has a few unique characteristics which I'll talk about. And then I'm going to apply that spindle rocking to a small project, which happens to be the very project or similar project to what I did when I went to David Lindow's in eastern Pennsylvania. And of course, lastly, I'd like to answer your questions if I'm able to do so. I'm going to compare what's different about it, what's the same. I'm going to talk about the rocking mechanics. Of course, an important thing to all of us is safety. I'm going to illustrate the paper chuck, which happens to be mounted on it's called a chuck. It doesn't hold a thing other than paper. And then I'm going to apply those rocking principles. And then I'm going to explain, if you want to go further, here's some places to start. Ornamental turning goes clear back, and I've got 1800s up there. I think the other day I discovered it's more like 1700s. The early machines were treadle powered. Of course, they were built before they were standard. So like if you buy an antique machine, You won't even have standard screw threads. In fact, the spindle thread is something like 5 3/4 threads for some unusual dimension. There's a good number of people that do that. The machines used to be owned by royalty because they were very expensive. I've heard the comparison being that a well-equipped machine would be the equivalent of a whole block of, say, row houses. So there's lots and lots of history, and as I say, 3 lifetimes needed. I've found, and also I might make a disclaimer here, a lot of these are my opinions. You may disagree, and that's fine, and there may be a better way to do things, so be it. But in ornamental turning, in my short experience, I've seen a lot of different things that people do. Of course, you might think, well, let's just create pieces. And yeah, I do a little bit of that too. I personally am caught in the thing, well, I like to build little accessories for a machine. And a lot of ornamental turning is being able to hold your work in a particular orientation relative to the cutters and the motions that you're going to create. But there's a niche of people that do collecting and restoring antiques. I have a friend in Chicago that he has 2 very nice wholesale machines, complete with walnut cabinets, and every accessory is in a beautiful walnut box. It's really eye candy to look at it, and he also works with it. Designing and building machines, there's a good number of people that design and sit down and procure parts and put together a machine, and some of them work very, very well. There's a bunch of people that grind special cutters, and there's a niche of ornamental turning called fixed tool work, where someone will grind a profile, a very careful profile, and they actually look at it with a microscope to make sure that their cutting edge is perfect. And instead of just wood, there's people that are working in precious metals. There's a field called guilloche, where essentially it's making fine scratches on a metal surface using the machine. There's some people that are doing faceting work in stones and the like, and of course many, many more. What are the comparisons? Of course, your plane turning, the only thing that happens is your spindle turns. With these machines, you've got the ability that the spindle can rock like this. And on this particular machine, you've got this ability. So you put a cam on it, and you've got the ability, oops, here, I've jammed it. You've got the ability for the machine to, oops, hit the bell, there we go. You've got the ability for the machine to go this way with a cam out here. We call a cam a rosette, and a little thing here, rubber, we call it. It's a follower that causes the machine to do this. And you can actually do those 2 things concurrently if you wish. That's one of the main differences. On your regular lathes, you have indexing on the back of your headstock. There's probably a 72-tooth wheel. In ornamental turning, there's many index wheels. On some of the old machines, there maybe be half a dozen of them. On this particular machine, on the pulley, there's, I think, 96. So there's multiple indexing to much more choices than you would have in the ordinary machine. By the way, these are 30,000 feet view. There's an exception to practically every one of them. And of course, with the ornamental turning, we have the idea is that we have a cutter in space that's turning. Usually it's a dynamic cutter. Now the fixed tool is not, it's static. But there's a cutter out here, and you use a mechanical device to control the position and of that cutter. Whereas on your regular turning, you just use your hands, and hopefully you've got very nice skills to make nice, smooth finishes. The work pieces on ornamental turning tend to be small. Some of the pieces can be, for example, like guilloche work, scratching on a watch face. And we had a lady not so long ago that she would spend 40 hours maybe making the pattern on a clock face for a high-end watch in Switzerland. Beautiful work. The work holding, anything goes. Of course, you use screw chucks and whatnot. A lot of your chucks, because they have common threads, this lathe has a 1" 8. You can use many of your wood-turning chucks on this machine. I will say, though, the big ones, probably not as necessary. Little ones, and actually I use a lot of little chucks that come from a company called Shoreline. The mediums, wood acrylics and more. The important thing in ornamental turning is it's good if your material holds patterns well. And some of the desirable woods would be blackwood, it could be kingwood, it could be mopani, and the like. Woods, domestic woods like oak, they just don't, because they've got so many pores, they just don't reveal the patterns well. And of course, in your plane turning, anything, oak, ash, maple, or what have you. Maple happens to be a reasonable thing if you're going to just a piece of junk wood and you want to try out your new design. It holds the pattern reasonably well, but nothing as well as the blackwood. Sanding. Generally speaking, ornamental turners do not sand. Now, there's exceptions to that. In my other demonstration, you have to use some light sanding to take off some tool marks. Of course, in your plane turning, you sand. And of course, this is all about surface embellishment. It's just another thing in your toolbox. And my style is I do very limited ornamentation, but some people ornament the whole thing. It becomes very, very elaborate. One of the downsides of ornamental turning is nothing happens fast. Don't expect instant gratification because it takes a few minutes or maybe takes an hour. Sometimes there's situations where I'll be running a pattern. It might take an hour and a half for the machine to traverse maybe this far to do whatever I'm going to do. So it doesn't happen fast. Like I say, it requires time and some patience. It's not like regular turning. You can turn out a bowl and in 15 minutes you've got the beginnings of it, and it looks pretty good. A characteristic of machines and tooling, because it's an old art and it's risen in popularity, say in the last 20 to 30 years. There's not a lot of commercial manufacturers. You can't just go out and say, I want the machine, and it shows up like a Robust or a Paramedic or what have you. You kind of have to decide what you're going to do and buy the machine for what your interests are. And this machine is a limited production. I think there's maybe, what do you think, Russ, 200 of these in the world? But there's, like the MDF machine, there's maybe 250 or 300 of those around. But a lot of people, they just build one. They sit down and study the problem. They'll maybe buy a bearing slide and put together a bunch of parts and a little bit of machine work and so forth, and they're there. Today, the rocking. The cam there with the blue arrow on it is a rosette. That one happens to be a standard David Lindow. The rosettes in this case are like a little over 5 inches in diameter. And what happens is that rotates like the blue arrow, and the follower, the rubber, is static. It's held to the body of the lathe. And because the middle of that is the axis of the lathe, it forces it away and allows it to come back. Now, to make that happen, on this particular lathe, there's a spring. And you can adjust the tension of that spring, but it forces those two together so that as it rotates, you get. Now, this particular one is a 16 bump. There's in the world of rosettes, there's all kinds of conventions as to what they are. What I'm going to do is the paper chuck. It's just a simple, ordinary 4x6 note card. I have a tool post mounted pin. I might say you have to use the space pen because you need pressure. The others don't work very well. Also, before we get too far about safety, just like turning, regular turning, you have dust. You have to be aware to keep your hands away from the cutters. There's some pinch points. Watch out. There's belts, pulleys, there's electrical, there's a few oils and greases, and like woods like cocobolo, some people have troubles. I know someone, they get a severe rash with cocobolo, so if you've got that kind of a problem, you maybe don't use that. If I were at home, I'd have a dust mask, and I have a dust collector, but that's not practical here. It'd make more noise than me. What I'm going to talk about on the paper is the influence of radial position on the patterns. What happens to the pattern as you change the radial distance from the center of your workpiece to where your cutting tool, or in this case the pen, is. And then what happens when you go with that pen to the other side of center? And I know a lot of you know this, but some of you won't. Let's see. Oh, okay. What I have done here, and what I should do first, because it rocks, when something rocks, guess what? It changes. It goes low. Same thing. If you can minimize the amount of that if you make the same distance that you're moving on each side of center. So the way to set that up, or a way to set that up, is do you have your camera on here? You need to get your camera here. Over here I have the rosette mounted. I have the rubber mounted there. One thing you need with this is a lot of Allen wrenches. Let's see, I think it's this one. Yeah. Now what I'm going to do is, okay, now it's just going to rotate. Now normally, if you had just a manual machine, there's a handle here, and it would turn the spindle. I'm going to cheat. I've got a motor on it, and that will turn the spindle. Now, what I need to do is look at how much rock that I have. And it turns out that is, when you look at the numbers here, if you stop it, it's 100 thousandths, a tenth of an inch. This is a dial indicator. It measures up to an inch, and there's a plunger. So what you do to center it, as I described, there's a machine flat on the front of the tailstock and, of course, the table. I have a machinist level. It's a glass one. I might comment, these don't last too well when they hit the concrete floor. I look at the level here, this direction, and for this to be parallel, I put the bubble in the same position, and it happens to be that. So if I want to adjust the proper position of this, I would want half of that 100 thousandths, so I move this to 50 thousandths. And if you'll see, I moved it from here around to here, which is 50 thousandths. And then I loosen up my rubber, and I just let it rest there, and it pushes it back So now I've got the machine set up so that it will rock equal amounts both directions. And so I've got it so that it's here to here to here, 50 thousandths each way. Now, I've used the rubber has a large radius. And what happens is that if you think about it, if you put a knife edge on that rubber, you get exactly the shape of the rubber. But if you put something that's like a radius, it won't go down in the space. So you've changed the shape of the pattern because of that. And I'm using, I think it's a 1.5 inch radius, so I'm not getting the full amplitude off that rubber. If you were to put the knife edge, the amplitude might be more like 160 thousandths. It'd be quite a bit more. But when you, okay, I'm going to go out here. Now, when you start out here, it's going to be much like the pattern of the rosette. Where's the camera? Here. Wait a minute. Yeah. Incidentally, one thing I've also done is you've got to worry about center vertically. And before you all arrived, I set this pin so that it's pretty close to center. I use a stick. That stick is the center line. And when I put that stick up there and eyeballed whether or not the pin was the same height as that. Some people don't need that crutch. I just happen to. Now, as you move in, again, center is more like right here. As you move in, what happens is that the space this way, radial or azimuthally around the perimeter, see how it's gotten, can't see that yet. It's getting, what's going on? Yeah, there you go. It's getting closer. Okay, and what I'll do, and what doesn't change is the amplitude. The amount of rocking doesn't change, but because you've got a smaller radius, they begin to squeeze up. Now, the interesting thing about this is that if you go beyond center, now center obviously is like right here. If you go beyond center, the bumps, it reverses. So the bumps become dips and the dips become bumps. And if you're perfectly vertical,
Or go further over, the way the camera is not high enough for them to see it.
let me see it. There. Yeah, maybe I'll go out here. There you can see it is coming around the top. Now, that's not perfect, which tells me that it's a little bit off center. If it was perfect, it'd look more like this one. But you can see where the bumps and the valleys have changed. Now, there's another setup that you could do to get the same thing. If your rubber was here and either here or there, if your rubber was here and you were on this same side, you'd get essentially the pattern of the rosette. If you come to this side, the near side towards the user, you get the reverse. Now, this machine only has the ability to put the rubber on one side. Some of the antique machines and the very high end, there's a lathe out there called a maid lathe. They actually have a rubber tower, or the ability to put the rubber on the back end. And sometimes you need that capability. It's useful. Any questions about that? Is that a... Okay, let me head back to the presentation. This is the simple project. It's a bottle stopper. It happens to be what I did. That is made with this rosette. And I'm going to do the outside, beginning on the near side, the first. And and I'm going to step down, and it'll give you a bamboo-like look. And then I will do the transition to the bottle stopper mechanical part, and then I'll come back and do the face of it. This is the workpiece. What it is, I think probably someone upstairs sells them, but it's just the brass insert. You drill a half-inch hole, epoxy it in. One thing I'll have to say about it is that if you choose to tap it, like with a 3/8, all these are 3/8/16 taps, it'll be truer. These daggone inserts, you put them in there, and this thing is like crazy when you put it out. The shank just happens to be a piece of 3/8 bolt that I cut, and I did put it in the metal lathe and straighten it up a little bit. It didn't run very true. But the one I'm going to use, I've gone ahead and straightened it out. Oh, yeah, here's the cutting frames I'm going to use. The left one is called a horizontal cutting platform. And as you can see, there's a little wheel on it that has, there's a pair of triangular cutters from the machine tool industry, and this little guy just turns. Now, I tend to put a piece of tape on it because there's a lot of dirt, and there's a little bearing there. The dirt gets in the bearing, and they don't last very long. And then I also put kind of a sight line down the middle of it, as you can see. To do the outlining, I'm going to use what's called a drilling platform, the top one in the picture. For some reason, I like 60-degree cutters. I've been criticized for that. Some people think you should have at least 90 or 120. I think for this particular application, the 60s are good. Of course, the key points I've just explained. Of course, I mount the workpiece in the chuck, which is here. I've got to change a couple things. Oh, yes, I'm going to change cross slides here. One note is these cross slides have an aluminum base on them, and I like to keep the travel of this absolutely parallel to the edge of that, because I use a tri-square against that edge and the end of the table to be sure that I'm square with the world. Is that necessary? No, it really isn't. In fact, some people do orient this thing in all kinds of directions. I tend to be rectilinear in the way that I choose to work. Let me see if I can get this guy out of here. The reason I'm using this is that it has a powered power to run the motion. One thing about ornamental turning as you're working, as you see, there's lots of mechanical adjustments. You're constantly tightening or moving or something. One good common sense thing to do is always go back and kind of check. Do I have everything tight? Don't ask me why I know that. This is actually what's called a curvilinear. It's kind of an advanced thing. You can change the position of the cutter by following a template. We're not going to use that feature today. We're going to just use straight translation. It's also meant originally that you run some belts off the crank and come up here, and there's a little gizzy here that turns and enables it to rotate and translate. Take me a minute here. One thing about this particular lathe, and a desirable feature if you're going to get into this, is to make sure that you have a Morse taper bore. The advantage of that is that, generally speaking, when you put something that's threaded on, it doesn't align. Like in plane turning, you take a chuck and you move it from lathe to lathe, and yeah, there's some run out. It's okay. It's pretty insignificant. With ornamental turning, that matters. And so what some people do is they have this mount, and it actually, here's what it looks like when it comes out of there. It's just a chuck mount, but you can move that from lathe to lathe, and that reduces your run out. Now, if you want to reduce it even further, there is a device that you can get. Essentially, it's a device that allows you to do this and this, or to straighten it up if you want it to be within a gnat's eyebrow, if you will. I need to get. This is just a standard AXA, it's called, tool post holder. These are used on, I think, metal lathes in the range of 12 inches or some such a matter. Okay, now I got to get this. Little bit monkey business here. Yeah, I painted this thing white. Hopefully it'll show up better when we go to work on it. Now, as you notice, this thing has a slight taper. What I'm going to try to do is, you can see it has a little bit of taper like this. This one has like 5 positions roughly. Each time I'm going to move it about 3/10 of an inch. Well, exactly 3/10 of an inch. One thing with ornamental turning is you need to plan. You need to see whether or not you've got enough motion for what you're going to do. Now, I need to come out to here with this, so you do tend to, here, I'm going to make sure I've got enough here. Now, the taper you could do several different ways. Obviously, you can loosen these and you can turn this. Once again, I like to have this travel to be parallel to that. So by eye, I can put my square on there, and this taper is roughly about 1/8 of an inch over that length, and I'm looking at the light there. You also need to worry about centering. what I need, not this. Yeah. And looks like I'm a little bit low there. This doesn't get you precisely, it just gets you close. Put my belt on. I like to store my, if I'm going to use my cutting platforms every day, you know, you can leave the belt on, but if they sit in the drawer for, say, a month or something, the belts will take a set. And then they don't run very smoothly. Now what I need to do is plug in my power from my feed here. Now, I don't know. This seems like it's... Okay, now what I tend to do to center, there's many, many ways to do this as far as vertical center of the cutting frame. Let's see, this thing's got a switch. I call it kind of like dynamic centering. I turn it on, and then I make a very light cut. Oh, there's something else I should check too. I want my cutting platform to be absolutely parallel to the table. Oops, not close. That one's not going to work. Allen wrench Haven. The way this this is called a universal cutting platform, is there's a set screw here where you can turn it. And what I want to do is adjust it so that it's parallel, because if I have it like that, and obviously I center it, I go over to the edge or the face of it, it's not going to be centered. Now what I do is I just match the oh gosh, here. Pulleys here. Which way did I go here? One thing that's nice to have is a little brass hammer to kind of coach things. Because if you hit that with steel, it will damage it. Not have very good luck here. You know, another level that works is there's a company called Wixie. They make a little box. I think they're originally made for like setting a tilting arbor on a saw. Now I've got that parallel. So my switch is right here. I don't know what. That indicator doesn't need to do that. Yes, it's nice to have a magnifier of some kind, unless your eyes are in really good shape. Now, what happens is when you're centering for this orientation, if you're too low or too high, it's going to look like a tornado. Either up this way or it's going to be like this. Just move it, try it again until that goes away. Now, unless you want a little dimple in the middle. I like to try to get rid of that as much as I can. It doesn't look to me like I'm too bad a shape here on this. You know, one thing I didn't look at is, do I have the cutter turned in the right direction? Yes, I do. Cutters don't work very well when you run them in reverse. I think I'll cut that a little bit deeper and see what it looks like. Yeah. There's a little tiny dimple. I'm not going to try to get rid of it. I'll stop that. Maybe you can see it. I've just touched that enough to, because that'll all be cut away when I come back and do the end. Now what I do is I just nominally put it there, and I'm going to move it like 5/16, 3/13. If you watch this, it'll go 50 thousandths, it'll go 6 times, and then it's going to go like, like a third. So now we oops. Now we try to cut the first bamboo pattern. Now, one thing about it is sometimes if it's rotating one direction, you won't be getting a nice cut. If you rotate it the other direction, sometimes it'll improve. Sometimes I've even turned the cutting platform back down because all of these cuts, it's going to be starting on this side and coming out this side. Now, sometimes you'll do your pattern deliberately to advance it, so you're always cutting away from the pattern. I'm kind of going backwards here, but it'll. You have to feed this in slowly. Oops. That belt doesn't. You can see it's beginning to make a little. Is that camera not working?
No, it's working fine.
Yeah. Now, if you're doing this by hand, what I do is, say I watch, this is called a bird, but I watch a position here, and then maybe advance it 20 or 30 thousandths. There's no speed I can say, oh, you run this at this speed and this at this speed. It's strictly by feel. It's just like driving a combine. You listen to it as you're sitting there driving it, and you decide if I'm going too fast, I'm going too slow, it's bogging up, it's whatever. The cutter will And what we want to do here is get to the point that it generates the full pattern. It'll take several rotations. See, I'm going a little bit too fast. It doesn't like that. It stops. As you cut deeper, the cutter gets confined, and like if you're cutting really, really deep, it's easy to stall it. No, I didn't like that. I didn't like that. This is African Blackwood, but I haven't said it. It doesn't like that, does it? This belt isn't as tight as it might be. I wonder if I can. This thing doesn't have enough weight on it. The belt tension's pretty minimal. What we're going to do theoretically is we're going to cut until the pattern fully develops. As I mentioned, this is where it's a bit slow. Yeah, that's aggravating. And I could pass this around. I mean, this is what I'm trying to do. Like that. You can tell that the piece is a little bit out of round, or it's running untrue. If you look here, it's fully developed right here, but see there's a gap there, which means that this piece isn't running absolutely true. When you're doing this, there's a lot that you can glean from not only listening to it, as I mentioned, but watching. Like right there, you know it's not true. Sometimes that matters, sometimes it doesn't. If that's a piece that it's got to be a certain size or something, then you maybe want to straighten it up with what I call the leveling chuck. Another thing to do, which I actually did here at home, is you can run down and rough cut or smooth the piece out, just run this real slow this way to make it perfect. That's why that dumb thing just doesn't like that. Oh, I'm sorry. No, I'm hand feeding it in to depth, and then the powered part of it is to index to the next position. It's set to move 0.313, which is 5/16. Oops. There's just not enough tension on that belt. This is someone else's machine that they were kind enough to loan. At home, I've got the ability to tension that belt, and it stays right there. It's a gravity thing, and you get what you get. Yeah, that's another thing I could do. And one thing about bearings, if you run them at full tilt, they don't last as long. Yeah, I'll just run it quite a bit faster. You can see, this is a DC, actually I think that's probably a Sureline motor, brushless motor, and a Sureline controller. Yeah, that's doing a lot better. Good idea. Now I think I'm at the point that the pattern's fully developed. What I need to do is preserve the position that I'm at here, because I'm automatically going to get the taper as I move down because this thing is set like that. I use blue masking tape for a lot of things. I will stick a little piece here on the side of my cross slide. So when this is at 0, it goes from 0 to 200, that I always come back to the same position, and I'll put it right there so it's right at the end of that tool, or someplace I can remember. Yeah, I'll just back out. Now what I just do is I move it. It's going to be a little over 6 turns. Start again. Yes, sir. No, I did not. That would be something you could do. What phasing is you have a sine wave, and it goes up and down. What you do is you move the ups to where the downs used to be. And the way you would do that, and what would happen is the pattern would split. I will do one of those. Now I have to do it a different way because my rosette's external. And there's a worm there. And one turn of the worm is 3 degrees. So because there's 16, there's 16 bumps. So I got to, whatever 360 divided by 16 is what? Somebody can do that in their head. and then you need half of that, because you take 360 and then you divide it by 16, that's 22 and a half. That makes sense. And then I need half of that, so I need 10 1/4 degrees to phase it. What I'll do is the next one I'll phase it to show you what that does. I'm looking at my piece of tape. You can't cheat. It tells you. The thing about it, when you squeak your belts, what will happen is you'll burn it, and then pretty soon off it comes. Yeah. Pedals here. You have to be patient. You put a little more tension on that would really help. Okay, that helps. Okay, I'm at the position where this direction I'm at the same as I was when I was doing this, so it's a fully developed pattern, and you can see the bamboo look that's appeared there. Now what I'll do this time is I will phase it to show you what that does. Yeah, I needed 10 1/4 degrees. 10 1/4 divided by 3 is 9 and a half. Okay, what I will do is I will turn this 3, 6, 9. Now what will happen is that on the back side, you'll begin to see that we're cutting in the middle of these, and you can see what I did? Now, if I was using here before I started, I would needed to select a position here that there's a 16 marked here somewhere, and then you can just go plus or minus that 16 to get the same effect. Yeah, that helps immensely. It makes it go quite a bit better. Probably what will happen is the middle or the end of this cut will end up being in the middle of this second one. And you see you get kind of a diamond pattern that generates there. Oops. Can't go too fast. Now, one recommendation is when you get to the end of it, if you want a really nice surface, you slow everything down, and then maybe just go around 2 or 3 times. You'll see it, like right now, if you looked at magnified, it'd be a little bitty striations from the tool marks, but when you run it multiple times and really slow, it'll actually go from a low sheen, from dull to a low sheen. I'm at the depth now. You can see what's happened. Now what I'm going to do is I'll go back to where I was. All I'm doing here is moving this part of the rosette relative to the workpiece.
And on this particular lathe, one time is 3 degrees.
This particular lathe, this one is 3 degrees, this one is 2 degrees. Have you made a mistake with that in the past? Yeah. I'm going to move him again. Do you understand how I came up with how much to move it? Now this will be back to the original, if I did it right, it'll be back to the original spacing. You see what it's doing is that it's starting to cut where the peak was before. And if you look at that carefully, you can see that the taper's developing. It's very subtle, but it's maybe about like that. Is there a reason I use? This. You don't have to do it that way. There are cutting platforms where they integrate the motor right into it. The problem with that is that it makes it hard to build the cutting platform so that it's got the ability to be turned. Because you got a big old motor here and it's kind of klutzy. You could do it if you really want to, but it makes it difficult. And by having this, I call it kind of like a dental tool, dentist drill.
I'm a retired dentist, so
Yeah.
I'm familiar with
Oh, all right. This motor doesn't have much oomph. It's only about a 10th horsepower.
But the other sound is good. Those other motors are very loud compared to
Oh, yeah, that's a good point, Russ. Universal motors, which is what you're going to have in like a power drill or whatnot, it's really a DC motor that's run on AC. They scream. And if you're trying to do this in the basement and the rest of the family's don't want to be disturbed, it's nice if it's quiet, or at least as quiet as this. We're almost here on this one. A lot of times when I'm working, I'll leave like 10/1000ths on diameter, and then that's my last cut. A deep cut is going to be typically rougher than a light cut. A lot of times when I'm finishing something, I'll only do like 2 or 3 thousandths off the surface, and then, like I say, let it run a couple turns, 3 or 4. It's kind of diminishing return as to how much you get out of doing that. Okay, I think I'm completely around here. Yeah, I'll call that quits. Move it again. This will be cut number 5. The motor that comes with this lathe for power feed of the spindle.
Are you rephasing it?
What?
Are you rephasing it?
No. I just. The motor that they have, or that they provide for that runs through the belt that's down here is a gear motor. It's a DC gear motor. And I have one at home, and my experience is that it's great for a range, but when you get, I found, in my opinion, I like to go slow. When you get slow, what it ends up doing is like this, and I got a very rough surface out of it. If you notice, the stepper motor, I think, is an advantage, and it's a different control system, but they run very smooth. And I noticed in my work as I was going along that when I got into the stepper motor thing, I said, wow, there's a great improvement. And there's some projects that you do where you only, well, let me explain. This is a project that's not done on the spindle. The spindle is like this. Your cutter's right here, and here's a case that you just do this. So here's a case where you can set the stepper motor to only go so many degrees, and it'll stop exactly there. And believe it or not, that's just a simple arc. But the eye is deceived as they come together. It doesn't look like a simple arc. But this is a case in point that you start like right here and you rotate up like this, and then you turn it like that, and you do the same thing. And actually what I've done is I've put Rose Engine patterns in alternate ones. But this is just mounted. And people, you don't need steel hardware. You can make stuff out of plywood, believe it or not. Because this is kind of like woodworking. You know, you can have the fanciest tools. Nobody sees the tools after the piece is sitting in the house, the highboy or whatever it is. They just see that. And same with Rose Engine. You could have a piece of plyboard here I say, carved out of a piece of steel with a cold chisel and a hammer, and that doesn't matter. It's just about holding it so that it's firm and predictable in the orientation to generate something like that. So that's a case in point that you don't use the spindle other than to do this motion for part of the turn.
You got 15 minutes left.
Okay. Oh, sure. It's just, I just call it an acorn. It's just simple threaded. Here's a case in point where you can use your regular lathe to hollow it. I just use a hollowing, a little laser, and I just draw a pattern. Actually, I've got some other pieces I could pass around here. This is, it's the obligatory bolt nut. These are some of the typical rosette patterns that you get. And it's a sampler, if you will. It's just the rosette patterns to show you some of the different kinds that you can get. This has been done with a curvilinear. You follow a template to get this, and then this pattern is, you just keep going and slowly advance. Yeah, there's some eccentric chuck work here. And these aren't really prized pieces, but, oh, thank you. Now I'll show you how to do those coves. The first one, and what I have is a washer there that's the right size, and that is just merely. Oops, I got to take it off with the rocking. I just take it back, set it back. You just let it turn and cut a radius. Now, I'm not going to finish that. What I'm going to do is show you how to do the, oops, well, I can't say I particularly. Let's see, I don't particularly like this thing. Now, if you were paying attention in
Swing it so the camera, you got the camera covered.
Okay, I've got the camera covered. If you remember in geometry class, if you had a circle that intersected with something, you get a parabola. Well, you just tilt this at an angle. And you'll see that, and you just now that's how you get something that, I mean, your cutters, this cutter has a 1.1 diameter, you're going to get a 0.55 radius, but if you want something that's just a little bit sharper, this is the way to do it, or a way to do it. Now, I'm not going to finish that. I'm going to come to the face. It's much more convenient when it's right there. Now, what I need to do is restore the horizontal. There we go. Now, I'll make it rock again, and we'll do the face. And what I like to do is like just come in like 45 degrees and do that corner. You kind of work both of these to get your position. Now, now this is a case in point. You look at what you got. I'm moving it back to where it gets where the edge of the cut matches the one I just did at 45 degrees. What's happened? The camera's not.
No, I'm just.
Okay. Now what I'm going to do is go in like 2/10 of an inch and then repeat that. I think I'll just do that again. I'm advancing 2/10 of an inch, 2 turns. This cross slide is, in the typical, is like 10 threads per inch, and this one is like 20. And let me see about, I'll try to do the cutting or the engraving. You know, I think what I'm going to get into here is that thing is in the way. See, if I planned well, I'm in good shape here, but maybe I haven't planned well. It looks to me like it's going to make it. What I'm just going to do is put a little bit of line engraving on there. Now, this cutter turns this way, this goes up, so this goes like this.
Can you move the light a little bit so it puts a better shadow?
Move what? The light.
The other way. There you go.
Now, what you got to worry about is center. I don't know whether a knot at center is the problem. To me, like I could go down. It's not quite right. What I'm doing is trying to get the point. Yeah, that's not too bad. What it'll do is it's going to there it goes. What I'm doing is I'm just putting a real fine 60-degree cut around the outside of that second cut to kind of border it. Make it a little deeper. That's wrong one there. What happens when you change platforms, these things do have these screws on them, but truthfully, in my experience, they don't work well enough, and you really should be fine-tuning it each time you're using it. So you can see basically what went into that piece that I passed you around. Okay. Go faster? Yeah. Yeah, you can see that it's got a nice little border that goes around that second cut. And then there's scallops like right here. Okay. Thank you. You think, well, you'll go to lunch, I'm going to finish it.